All right, I'm going to show you how to do number 5 on the Atwood and modified Atwood practice. We've done 1, 2, 3, 4 in class, and this time we're just adding some friction to our angled table. So we have an inclined plane that has a mass on the plane, and it's over a pulley, and then we have a hanging mass over here. This is identified as mass 1, and this is identified as mass 2. I will mention this in class, but you should know that some of you did not identify 1 and 2 for your objects for the lab. You put A and B, and then you used M1 and M2 for your calculations, and it was a little bit hard to follow. So you need to be consistent with how you're going to identify your masses. All right, and we were also given a mu of 0.15 and a theta of 30 degrees. So it says the student moves the mass back to the table with a rough surface to check their work on the table. The leg broke again. What? Create an inclined plane scenario. The masses are still 0.4 kilograms, and mass 2 is 0.6 kilograms. We're hung as shown in the diagram, what I drew here, with an angle of 30 and a mu of 0.15. We want a free body diagram for each scenario, our tension and our acceleration. So for M2, our free body diagram looks like this. For M1, our free body diagram looks like this. Tension. All right, so the tension is my action-reaction pair, so the tensions are going to be the same for both scenarios. I can assume this thing is going to be accelerating up the incline and down because my mass 2 is larger. And now I'm going to sum my forces. So the sum of my forces for mass 2 is just going to be my gravitational force minus tension is equal to MA. You guys did not identify your mass when you put MA. I'm glad that you did for your lab, but you need to be a little bit more mindful of your writing your equations out. All right, so the sum of my forces for block 1 that are parallel to the plane is going to be tension up the plane, acting opposite of my frictional force, and my sine component of mg. And they are accelerating at m1a. The sum of my forces for block 1 that is perpendicular to the plane is my force normal minus my cosine component of mg is going to be equal to 0. Another scenario, this thing could be stationary. This could be in equilibrium, and therefore we would say set this force equal to 0 and this sum of forces equal to 0 as well. I gave you some other variables in there, so we're going to solve for tension and acceleration, but you could have just as easily solved for tension when this thing is not accelerating. All right, so let's see what information we have here. We can figure out what my force normal is, right? My force normal is going to be equal to m1g cosine theta. And let's check out our equations, like 1 unknown, 2 unknowns, 3 unknowns. I got 1 unknown, 2 unknowns. So I want to find out what my frictional force is here, so I can reduce the number of unknowns in my equation. Theta is my frictional force. So I'm going to take that, plug it into here. My equation becomes T. I'm going to distribute this minus. The reason I set it up like this is I have my up the incline force acting opposite my two forces that are down the incline. If I resolve this vector here, all right, we don't want to do the components on our free body diagram, so that's why I'm drawing it in red so you can see. But we've got the part of my mg is going to be acting in the same direction as my frictional force, just like the FRQ that we looked at on Friday when the block was sliding up the incline. And then I have this component of my mg is going to be acting opposite of my force normal. All right, so I'm going to distribute this negative. So minus my frictional force, which we figured out to be m1g cosine theta, minus m1g sine theta is equal, oh, I ran out of room, m1a is equal to m1a. So we got our two equations, this one and this one, that have two unknown variables, my tension and my acceleration. I am going to solve for tension on this one by adding mu mg cosine theta and mu mg sine theta to the other side of my equation to get t by itself. So it becomes t is equal to m1a plus mu m1g cosine theta plus m1g sine theta. Now I can take this whole thing and plug it into here. And I'm going to write it down. I'm going to write it down here. So it becomes m2g minus tension, which is m1a plus mu m1g cosine theta plus m1g sine theta is equal to m2a. That's a long one. All right, we need acceleration by itself. We have all the other variables. You're welcome to plug in your numbers as they are right now. I'm going to rearrange to solve for A just because I like to have what I'm looking for isolated. I'm going to distribute the negative and do a few more functions at one time. So m2g minus mu m1g cosine theta minus m1g sine theta is equal to m2a. And then since this is subtracting, I'm going to add it to both sides plus m1a. All right, you can factor out the acceleration, so it would just be a m2 plus m1 is equal to this whole thing. And then you would divide both sides by m2 plus m1. Hopefully you are able to recognize we are always adding our masses on the bottom here, equal to A. So this whole thing is going to be equal to A. Now we can plug in our numbers. My acceleration is equal to m2, which is 0.6 times 10, minus my mu m1, which is 0.4 times 10 cosine of 30 minus m1, which is 0.4 times 10 sine 30 divided by 0.6 plus 0.4. Okay, so this is 6 minus, let's get my calculator out here. Cosine times 4 times 0.1 So this whole thing is 0.52 minus 30 sine, right, 0.5 times 4, so it's minus 2 over 1. So, what is that? 3.48 meters per second squared. Yowza. All right, that's my acceleration. My tension is going to be easy because I just have it here. Rearranged, this one rearranged, it becomes, I don't want to plug it in here, it's too much. M2G minus M2A is equal to T. I subtracted the T from both sides, subtracted the M2A from both sides, rearranged it like this. M2 is 0.6 times 10 minus 0.6 times, we're going to round it, 3.5. So 6 minus 2.1 gives me a tension of 3.9 newtons. All right. Just because you know I like to, let's rank these forces here. So M1G is 4 newtons, M2G is 6 newtons, my tension is 3.9 newtons. My frictional force, I don't think we solved force normal, is going to be equal to, we have to do a few of these. Okay, so my frictional force is mu force normal. My force normal is going to be equal to mg cosine theta. So 30 cosine times 10 times 0.4. 3.46 newtons. Let me write this out. Right, we figured it out to be this here. So it's equal to m1g cosine theta, 0.4 times 10 cosine 30. Okay, and then my frictional force is mu force normal. So I'm going to take the 3.46, multiply it by 0.12. or 1.5, giving me 0.52 newtons. Is that all of them? 1, 2, 3, 4, 5. We got our 5. All right, so the most is going to be M2G is greater than M1G, is greater than tension, is greater than my force normal, is greater than my frictional force. There you have it. The end.